It's the hardest thing to remember, and it's really painful when I don't do that. Um, let's see. So yes, so we go to here. We search for Python, and when you click on that, it'll bring up your interpreter. I'm going to increase my font size so that it's easier to see if I type anything in here. And of course, we have our 3 greater than symbols, which is the Python prompt. And let's type a few things in. So if we say 2 plus 2, go ahead and type that in, and you'll see that you get 4. Does that work for everybody?
Yeah, it worked.
Yes.
Yeah, so we've got basically, right now we're working at what's called the interactive interpreter. That means that we write one line of code in and it executes it right away, immediately. Later on today, we're going to actually make a program, but for now, we're just going to play with the interactive interpreter. And you can see that I can write, I can do any kind of, large calculation and it'll do it. So let's go through the different symbols. So so addition is like that. Subtraction would be with a minus sign. And then multiplication. Well, multiplication is just 7. And we don't want to use an X. We use an asterisk. And the reason is that we're going to learn later on that we can create variables, and X is a valid variable. So in order to differentiate between a variable X and the multiplication in programming, in almost every language, it's going to be an asterisk. So if I put 7 times 8, I get 56. And if I want division, I use a /. So those are our 4 main arithmetic symbols: plus, minus, asterisk, and /. And the asterisk is for multiplication, and the / is for division. Does that make sense?
Yeah.
Now, as I go through these examples, I don't have the ability to see if people are getting it as easily as I do if I'm in the classroom. So what I will do is, so please let me know if I'm going too fast. Just you can either type in the chat, hey, could you go over that again, or just ask, with your microphone, and I'll slow down. It's just part of the reality of working online that I can't see. Normally, I look at people and I can see them looking up, and then I know that they're done. Or I actually listen to keyboard clicks, and I can't hear your keyboards up here. So, so let's take a look at. Now, there's some other arithmetic operations, and one is actually I'm going to do 3 /5. And what that is integer division. So watch what happens. If I do 3 /5, it returns 0. And if I were to do 5 divided by 3, it returns 1. This is the integer division operator. And the difference is that with integer division, it basically throws away the remainder. It just gives you what the whole number is after the division. Does that make sense?
It does. Mr. Garner, can I ask you a question real quick?
Sure.
On when you did the previous example of 7 divided by 3, it came up with a float, but you didn't tell Python that you wanted to use a float, and you didn't use a float in the original equation. Why did we get a float return without you telling it specifically that that you wanted a float return?
Excellent question. And what he's referring to, what he's referring to is that in other programming languages, if I just write 7 as opposed to 7.0, it interprets this as an integer and would treat this as integer division. Starting with Python 3, everything defaults to floating point math unless you use like this integer division operator. So in this case, I could even do 3.0 divided by 5.0, and note that it gives me back a floating point number, but it's actually done integer division with this. So the difference between integers and floating point numbers are the integers are whole numbers. Floating point numbers have a decimal portion. And in Python, a single slash means it will do floating point math. And so it'll convert this over into a floating point number in order to do it as a floating point division. Whereas the double slash is integer math and will return a whole number result. However, if there's two floating point numbers, it'll do the integer division and then give it back to you as a floating point number. Does that make sense to everyone?
Yes.
Yes.
So that brings up another operator that's kind of related to this, which is the modulus operator. And so if I did 5 divided by 3, or 5 integer division 3, 3 goes into 5 one time, and then we throw away the remainder. But what if we wanted the remainder? We have this thing called the modulus operator. And so what's the remainder of 5 divided by 3?
Two.
Yes, 3 goes into 5 one time with 2 remainder. And that's what the modulus, the percent operator, does here. It gives you back the remainder. This can be useful in programming because let's say that we have some value we're looping through and we want something to happen every third time. Well, you know, if I do 1 mod 3, I get 1. If I do 2 mod 3, I get 2. If I do 3 mod 3, I get 0. Then 4 mod 3, I get 1. 5 mod 3, I get 2. 6 mod 3, I get 0 again. So I can actually look at a value and take the modulus of, like 3, and that means that every time that equals 0, I could we're going to learn later we can use an if statement to make it do something, say every third time, or if I took the modulus of 5, every 5th time. So this modulus operator is actually very useful in some applications in programming. And so now you have integer division, which throws away the remainder, and then you have the modulus, which throws away the division and just gives you back the remainder. So you can get the main part and the remainder with this. Does that make sense?
Yes. I just had a quick question. So the modulus, you said, throws away the division and just gives you the remainder. So instead of finding the remainder, the modulus helps you just do that?
Yeah, the modulus just gives you back the remainder.
Oh, okay. And then the integer division just gives you the division and not the remainder, right?
Yeah. Yes.
Oh, okay. Okay, perfect. Yes. Cool. Thank you.
So try these. Try 10 divided by 3, 10 mod 3, 9 divided by 3, 9 mod 3. And then look at the last one. And before you do that last one, try to predict what it will do. So now we're taking, in the last one, we're doing the modulus of 2 floating point numbers. It kind of makes sense what the remainder is with whole number division, but what's the modulus with floating point numbers? And so do those 4 there, and then before you do the 2.75 mod 0.5, try to figure out what it will do. And the way to think about this is, what's the algorithm? How does the modulus operator get at its answer? What process does it do? So, 10 mod 3, it's going 3 goes to 10 X number of times and then has a remainder of. So with the last one, using that same process, try to figure out what that operation will do and what it will return, and then do that and see what it does. So I'll give you a few seconds to do that. Okay, so here we have, if you do 10 divided by 3, you get 3.333. If you do the modulus, you get 1, because 3 goes into 10 3 times with 1 remainder. And then with, 9, divides evenly with 3. The 2.75 mod 0.5 gives you back 2.5. So how does that work? Well, and forgive my mouse writing. So if we take 0.75 and we put 0.5 into that, well, 0.5 is going to go into that 5 times. 5 times 0.5 should be 2.5. If this is the same way we still do math, right? I know that there's new math, and then there's a whole bunch of other stuff, and Common Core math and all the stuff that happened, but this is how I learned how to do math. So 5 times 0.5 is 2.5, and we get 0.25 as a remainder. And so this is the remainder, and that's the result. So basically, we just do the same thing. Even if it's floating point number, you divide this into that, and whatever is left over is your modulus. Does that make sense?
Yes, that does.
So we don't use that often, but it is an interesting thing, that could be useful perhaps. So, and what you're going to find is with Python, they don't put a whole bunch of rules on how to use your operators. If there's a way for it to work with anything, then they will generally have written the language so that it does something, with it. So it's not a language that throws a lot of errors. The great thing is that it does what you tell it to do. The truly scary, horrifying thing is that it does pretty much what you tell it to do. So, hopefully you told it to do things that you wanted it to do.
Hey, Robert.
Yes.
Is there a way to use 2 operators at once?
Yes, so you can string these all together in a formula. So for example, let me bring up my window here. I could say 5 plus 3 divided by 2.7 plus 24, and it will do that whole operation all there. And we're going to, and we're actually going to look at that in a second. We're going to look at how to force the order of operations. So, those operators give us the division, the remainder, and we can see that it even works with floating points. So try this one. Put 2 asterisk asterisk 3 and you should get 8. What operation is that doing?
Is that doing 2 to the power of 3?
Yes. And this is a little different than other languages. So not all languages have an operator to raise something to a power, but Python does. And so if you put 2 asterisks, that's exponentiation. So that is 2 raised to the 3rd power. Now try this one. Try -3 raised to the 2nd power, and then -3 in parentheses raised to the 2nd power. What should that first one return?
-9. -9.
Yes. So give it a try and see what it does. And it's kind of interesting. If you were raising -3 to a power in math, you would expect +9. If you do this in the computer, though, the computer is kind of rigid in how, or the programming language is kind of rigid in how it does things. And so what's higher order of precedence, exponentiation or addition, subtraction?
Exponentiation.
Yes. So what happens is, raising a number to a power takes precedence over negation. And so that's equivalent of saying -1 times 3 squared. And so in the computer, we have to force that by putting our negative number in parentheses first to force negation to happen first, and then we can raise it to the 2nd power. So that's a little different than your notation that you're used to working with in math, perhaps. And so you're going to find that math and the computer, they're similar, or math and programming are similar, but not exactly the same. Sometimes the symbols have a slightly different nuance in what they mean. Okay, so we have basically the fundamentals of math there. We have addition, subtraction, multiplication, which is the which is the asterisk, and division, which is the /. We even have integer division, which is the double /, and we have exponential, or we have the mod with the percent and exponentiation with the double asterisk. So that gives us really kind of the fundamental arithmetic operators. The next thing we need to be able to do to be able to write code is we need to store our results, because a lot of times you're not going to do everything in one big formula. You're going to do a little piece of the formula and store an intermediate result, then do another piece of the formula and store an intermediate result. So we need to store information. And to do that, we're going to use something called a variable. And what a variable is basically it's a piece of memory. And in point of fact, it's actually random access memory. So we can declare a variable by just providing a name, and Python will then save a piece of memory for us and use our name to access it, and we can put values in it. So if you do this, you say x equals 3. X is a variable. This is the variable right here. And so try this. Say x equals 3, and then type x and see what happens. So what you should get is when you type the variable x, it will return the value stored there. So that's actually, so when you see this equal sign, I recommend that you don't say equals. What I recommend is that you say is assigned to. So here we're going to say x is assigned the value 3. And the reason why I say the reason why I say this is not really equals is in math, equals is designates equality and is really building a formula where you can pass things back and forth between the two sides of the equal. You know, if you do everything on the right, it does it to the left. It's not really the same thing as that. This is really assignment, not equivalence. So in programming, I recommend when you see a single equal sign, say 3 is assigned into X, or X is assigned the value 3. Does that make sense? That saying it that way should help avoid some errors. Now, given that in order to put something into a variable, you have to have an equal sign. If I say X times 2, first off, what's that going to return?
6.
That will return 6. The question that comes up is, has that modified X?
No.
No.
Yeah, and really at this point, if this is your first time programming and you said yes or or no, there's no way to know until you know what the language does. This really depends on how they design language. Now, most languages, this will not modify X. Actually, I think I don't know of a language where this was actually modified. So if you put X, notice that X still has the same value. So to modify a variable, you have to have the equality sign, and that is what specifies that you're assigning a new value to it. So, if I do this, I say X equals 3. I've assigned the value 3 into X. I can see that that's what's in there. If I say X times 2, I get the interactive interpreter will evaluate this expression and tell me that evaluates to 6. But if I put X, it's still there. Now, let's say I wanted X times 2 to be stored in X. Well, I can do that, but I have to do this. I have to say X equals X times 2. So now this statement is saying, hey, multiply X times 2 and store whatever that is back into the same variable X. And if I do that and now display X, I can see the X has in fact been modified. I could also create another variables, maybe say Y, and say that Y is equal to X raised to the second power. And now I could see Y has a value of 36 and X still has a value of 6. Does that make sense that we can only modify a variable by assigning a value back into it? Just doing an expression doesn't change the variable.
I had a quick question.
Yes.
I was just curious when actually inputting the code, should we space it like that, or does it work without spaces, or?
It generally works. It worked that way too.
Mm-hmm.
And so a lot of times the spaces don't matter unless it does kind of jam two identifiers together and then the interpreter thinks it's all one identifier.
Oh, okay.
Okay, so our identifiers can be letters, digits, underscore characters, and they can be upper or lowercase letters. The only restriction is that you can't start a variable with a number. And, for example, if I wanted to store my name, I could say n equals Rob Garner. But that's not very good. It's not easy to understand what n is. If later on in my code I see this variable n, it's not clear what it is. So if I want to store a name, it's much better to use a verbose name for my variable, like in this case, name, than it is to use just a single character. So I'm going to ask you when you write your programs to use, variables that if I just look at it, I can understand what's going on. If you use good variable names, it'll do a couple things. One, it'll be easier for someone else to read your code, but more importantly, it'll be easier for you to read your code. And that will actually make you code faster. When you're dealing with more complex programs, what ends up happening is you're going back and forth and reading what's going on. And if you use and I've seen more than one time where, a student gets completely confused because they used a name that implied the wrong thing and they couldn't figure out what was going on. So using meaningful and verbose names, variable names, really helps out. In fact, what you can often do is you can use compound words. And so you can use the underscore character to do that. By the way, here we're assigning a string into a number. So we've done things with putting numbers into a variable, but we can also put text into a variable by just putting our text between double quotes.
Does it have to be double quotes or can it be single quotes? Because I saw some of the code came out different with single.
Yeah, in Python, single and double quotes are interchangeable.
Okay, thank you.
And then note that you can remember how I said that Python just tends to use make operators do something. What did the plus do with two strings? By the way, this is called a string. Text between two quotes is a string. So what did this plus operator do with these two strings? They're not numbers. It didn't add them together. It just concatenated them. It just put them. And so if you use the plus operator with a string, it'll just mash them together and make one big string. So notice that Rob Garner here is between two quotes, and it took first name, which was Rob, and last name was Garner, and combined them together. Make sense?
Yes.
Yeah.
Thank you.
And so, of course, we'd want a space there. So what you might sometimes find yourself doing is doing things like this. And then you might do something like this. Say name equals first name plus a space plus last name. And now if I look I can see that I stored that into this variable called name so that I have it available whenever I want it. So variables can be used for numbers. They can be used for strings. Addition works for both numbers and strings. Of course, even multiplication can work for strings. So we could say, so Python just kind of does stuff. Division and subtraction, not so much. But if the developers thought, well, we can probably make that mean something, they kind of do that with Python, and it just kind of works. Pretty cool. Okay, your variable identifiers can be letters, digits, underscores. The underscore character can be used to put between compound characters to make your identifiers be meaningful. Another way is there's also camel case and Pascal case. Camel case means that we capitalize each subsequent compound word. That can also be used as well. So those are ways that we can create identifiers. And again, if you make them meaningful and you make them descriptive, it really helps make your code easier to read. I kind of apply the standard when I'm programming that I want my code to be clear enough that a programmer can read my code one time and knows what my intent is. And that the way I do that is by using really meaningful variable names and really meaningful function names. And then if I need to, I'll throw in a few comments to make my code make sense. And we'll discuss comments in a little bit. Okay, so there's this concept in that is useful to kind of understand what is a statement and what is an expression. So if you type in x equals 3, notice that nothing's returned. But if I say 3 times 4, at the interactive interpreter, it returns a value. So x equals 3, or x is assigned to value 3, is actually a statement. And a statement is where you're telling Python to do something, but it's not something that itself results in a value. An expression like 3 times 4 is actually something that can be evaluated and returns a value. So at the interactive interpreter, what happens is if you just type in an expression, it will evaluate it and tell you what that expression is. If you type in a statement, it just does it, but it doesn't actually return a value. So that's the difference between a statement and an expression. So I think we did these. Notice that when we said x equals 3, that's a statement. When we type in just x, well, that's, we said x equals 3, that's a statement. And so that statement says, hey, put 3 into x, and it doesn't really, equals doesn't really evaluate to anything. But when we put x, that's actually an expression, because that's saying, hey, you can actually evaluate that to a value, and so it displays 3. Similarly, if you put x times 2, that evaluates to a value, so the interactive interpreter will display that. There is kind of an exception here. If you notice that the print statement, print is actually a statement, but because the action associated with that statement is to display something, the print statement will actually display hello world. So right now we've been working with the interactive interpreter. And we're going to learn later on that when we write programs, as opposed to just typing in code at the interactive interpreter, what you're going to use almost exclusively are statements. You're going to use expressions as part of statements, but you're always going to want everything to be a statement, because in a program, it actually won't display the value of an expression like it does the interactive interpreter. So hold on to that concept of statements versus expressions. Now, the next thing that we're going to want to be able to do is get input from the user. So the program that you're going to be doing later on, you're going to need to do basically 3 things. You're going to need to get input from the user, do math, which we kind of done demonstrated how to do that so far, and then display output, which you do with the print statement. So the one thing you're missing now for the program that's coming up is how to get input. To get input, we use an input statement. So go ahead and type input life, universe, and everything. And input is kind of like the print statement. When you do that, what will happen is what you put in these parentheses, this string here, will be displayed as a prompt, as an input prompt. And anyone read Hitchhiker's Guide to the Galaxy? Does anyone know what the answer to life, the universe, and everything is?
42.
42. So let's put 42 in there. And once you do that, you'll see that at the interactive interpreter, it actually returns the value 42 in parentheses. I mean, yes. So is that a number or is that a string? Yes, Jared got it correct. It is a string. So the input command here, actually, it gets the user's input and it gives it back to you as a string with the characters 4 and 2 in it. Now the input state, this is actually a statement, but it's also another example of one that actually also, it's one where it's a statement that actually evaluates also as an expression because, as we saw at the interactive interpreter, it returns a value. And this is nice, but the problem is that if we write more code, how do we get access to that 42? We can't. So what we generally do with the input statement, first of all, did that work for everybody?
Yes.
Yeah, so what do we think we need to do with that 42 in order to be able to use it later?
Do we need to assign it to a variable?
Exactly. So let's do this. Let's create a variable called x, which actually isn't a very good variable name because we don't know what x is. But for purpose of this example, we're keeping it kind of short. Equals input, and then for our prompt, we're just going to tell the user to enter x. By the way, actually, you'd probably want to say something like, please enter, a value for x in meters or feet. Generally speaking, when your prompts, you kind of want them to be very descriptive. And you kind of think in terms of when I write a prompt, what I'm really doing is I'm controlling the user. People think that we write computer programs to be controlled by human beings. It's really the other way around. We write computer programs to control humans, to make them give us information that's useful. So this actually isn't a great prompt because it doesn't tell us the units and it doesn't tell us what X is, but this is how we'll write it for this example, just because we want to keep it simple. So say X equals input X, and then run, then it'll put that and you put in a value, then say Y equals input Y, and then put in a value, and then say print X plus Y and try to predict what it's going to return. So let's see, 4 and 2 is 6, 4 and 3 is 7. So 34 plus 42 would be 76, I suppose, if you were doing that as math. What do we think this is going to return before we hit enter? And what do you get? Yeah, we should be getting back, we want to get back. I mean, clearly that we wanted numbers on this, but we got 3442. So remember how I said that input returns a string? It just returns the characters 3, 4, and 4, 2. And we saw how earlier when we took two strings and added them together, it just mashed them together. It concatenated them into one big string. So 34 plus 42 at this point ends up being 3,442. If that was what we're doing to our own bank account, that'd be wonderful, but that's actually not correct math. So how do we fix that? Well, what we can do is we can use a conversion function. And so there are two, the two arithmetic or the two numeric so if I say x equals input x, and then I put 34. If I look at x, notice there's these quotes around this. This is actually a string. I can convert that over into a number by putting int or float around it. So these are really conversion functions. And there's a lot of conversion functions in Python. Basically, you put the type of thing that you want as a function call, and a function call basically is where you have parentheses and you put in either 0 or more arguments here. So this is actually a function that will take whatever you pass to it and convert it into an integer. This is a function that will take whatever you pass to it and convert it to a float. So we often do this all in one. We do something like this. X equals float input X. So the input statement will give us back a string. Float will convert it to a floating point number, and then that's what ends up getting stored in X. And then we say Y equals float input Y. And now that these are numbers, it'll actually do math. Does that make sense?
Yeah.
So this is how you're going to mostly bring in numbers. And if you want a string, you just use input. And so float or int are your main numeric conversions. Okay, so up till now we've been using this console, and this is fine and all. And I like starting off with this because you can, let me see if this works. At a command prompt. Notice at a regular, any command prompt, you can enter Python, and then, so if you're a system administrator or something like that that's in the command prompt a lot and you want to do some calculations using Python, you could just type Python if you have it installed and start working at the command prompt there. So, so that's nice. We're going to start working with something called idle. So to get to idle, type idle. Do a search for idle and open up and double click on that. And what will show up is something that looks very similar to what we've just been working with, except that you also have all of these menu items. And, there's all kinds of things in here. I'm going to use the configure to change my font size. You don't have to do this, but this makes it easier for people to to see what I'm typing. And this does basically the same thing. You know, you've got the command prompt. And you can type, you know, commands. Does the same sort of thing. So this IDLE is called an integrated development environment. And it used to be that when you're writing programs, you would use a text editor like Notepad, and then you would use a compiler, and then you would use a linker, and you'd run all these programs to get your program built. Programmers are lazy, and so if we can automate anything, we do. And so they put all that stuff together into things called integrated development environments. And what this allows us to do is make a program, and it gives us a text editor for it, and it does all the build steps and everything for us, so we can just hit F5 and run our program. So, you know, we just did this. And so we're going to start using IDLE now. So let's try this. And IDLE, go ahead and type 2 *** 3. We get 2 raised to the 8th power. And now try this. Put pow 2,3. So this, so you can raise a number to a power by using the arithmetic symbol, which is what, or operator, which is what we're using here. So we here with the double asterisk is the arithmetic operator to raise a number to a power. There's also an equivalent function, and the function, and then what a function is in programming is we have an identifier for the function, and then in parentheses you can have 0 or more arguments. Well, for power, to raise a number to a power, you need to know 2 things. You need to know the number that you want to raise, and then the power you want to raise it to. So we have 2 values in here, 2,3, which is this function basically raise 2 to the 3rd power. So why do we have functions? Well, I once learned a language called APL. It stands for A Programming Language. And is a programming language for mathematical operations. And basically, they had operators for everything. And you had to get a special keyboard overlay to get all the, so you knew where all the special symbols were for all of the operations. And it was a great language other than the fact that after you wrote it and you had the sea of operators, you kind of had to like read through a manual in order to read your code. And so people would call it a write-only language, because once you wrote it, you never wanted to go back in and try to debug it. It was just too difficult. So functions are really nice because they all follow kind of the same structure. We have an identifier for the keyword associated with the function. And then in parentheses, we have all of our attributes, and all functions are laid out the same way. And that means that we don't have to remember a lot of different syntax for a lot of different symbols. And so in Python, your basic mathematical arithmetic operations have operators, but your more complex mathematical functions will be written in functional notation like this. Does that make sense?
Yeah.
And if you run that, you'll see that you'll get the same result. So you could use either one. You could use the arithmetic operator, probably for exponentiation. Now I'm going to use ***. It just makes more sense. But there's more than power as a function. There's actually functions for everything. There's sine, cosine, tangent. There's absolute value. There's a bunch of stuff that's out there, and there are libraries that have a whole bunch of other functions that you can use. And so if you import those libraries, which we're going to see in a bit, you can actually get pretty much access to any kind of mathematical or other function that you want. And we're going to see that functions can be used for more than just math as well. So we say that you call a function, and when you call a function, you put the name of the function, you open it with parentheses, and then you put 0 or more parameters. If you have more than one parameter, you separate it with commas. If you have no parameters, what you're going to see is open and close parentheses, one after the other. You still need to have the parentheses, because the parentheses are what tell Python that you want to execute this thing as a function. So a question was asked before, can we combine this all together? Yes, you can. So go ahead and type this one in: 10 plus the power of 2 raised to the 3 raised to the 5th power divided by 3.0. And after you do that, you'll get a number. By the way, this is in scientific notation. The E means times 10. This E plus 72 means times 10 to the 72nd. That means we have 4.7. And really, if you move the decimal point 72 to the right, that would actually be the full number. But whenever a number gets beyond a certain level, Python will automatically display it as scientific notation, just because they don't want to put 5 kajillion zeros after it. So, if you 3 to the 5th power and then raise the next thing to that power, you get a really large number. So parentheses will force the order of operations. Exponentiation is the highest order of operations, so that gets done first. Then the power function gets done. Then the division gets done, and then the addition. So you can write, full up formulas for that. And there's a link here to evaluation order. And so try this, say 3 plus 5 divided by 2.0, and you should get 5.5. And then rewrite it using parentheses and try to predict what the result will be. So if we do that, you should get 4. And why is that different?
So they added first, the parentheses.
Yeah, the parentheses force the order of operations. So in Python, the order of operations is similar to what you've learned in math. Exponentiation has the highest order of precedence. Multiplication, division, and modulus is the next level. Addition and subtraction is at the bottom. And note that, these are all at the same level, and they're done from left to right. So first, all the exponentiation from left to right gets done. Then all the multiplication, division, or modulus operations are done from left to right. And then the addition, subtraction operations are done from left to right. So these are all at the same levels here. And if you're not sure, you can force the order of operations. So yes, PEMDAS. Now, if you aren't good at figuring that out, here's the thing about programming. What you do is you do your best guess, and then you throw test cases at it. And if it's not giving you what you should be getting, then you can start trying to force things with parentheses and get it to work functionally. So, in math tests, you have to get it right away. In programming, you get to test what you're doing and try over and over again until you get it right. And that's actually why we have this term called fail early, fail often. We try everything and then get it to we test it and then use that to function, make it function. So let's I'll continue on for a little bit. Try this. Do ABS minus 10, 1 divided by 2, and then round 1.0 divided by 2.0. So if you do that, what does ABS do? Yep, it's absolute value. And you're going to find that there's a lot of functions out there. I don't know every function that's in Python or any language. In fact, after learning several languages, I often get confused between the different ones, and I lose track of what they are. The trick is that if I forget something, I will go to the Google and I'll put the name of the programming language and the name of the function I'm looking for, and I'll look it up, and then I get it. So programming is very much a using documentation to figure out how to do things type of activity. So yes, you do need to know a lot of fundamental code to be able to be functional, because you can't be looking everything up all the time. But the best way to learn this stuff is by building things, and you're not going to know the entire language. So ABS though and a lot of it kind of makes sense. Okay, we did 1 divided by 2, got 0.5. If you do round 1.0 divided by 2.0, this one's kind of weird, actually. In the last hour, I find out that I think there's actually a bug in Python. Because if I do round of 1.0 divided by 2.0, I would expect that to be 1, because the round function, if I do 1.5, for example, it rounds up. But if I do round 0.5, it rounds down. So there's something weird about the way it's doing round. It must be maybe if I do 0.500. Oops. Yeah, it's still rounding down. If I do round 0.50001, it'll round that up. So there's some weird thing about the round function. I don't know if it's a bug or what, but that should round up. Okay, let's take a 10-minute break. We'll reconvene at 10:40. 12:40. And we will continue on talking about importing modules. Okay, can everyone hear me and still see my screen?
Yeah.
Yes.
There's some built-in functions that you get with Python, but there's also some, you can import libraries that bring in some more functions. So try this, import math, and then type in math.floor 32.9. And what you should get is 32.0. So the floor function basically rounds down or truncates down, really. And you could do things like, combine that with the int function, and it would actually, like here, it made it 32.0. If you wanted that to be an integer, you could convert it to an integer using the int function. You could also just do int 32.9, and it'll give you a 32. But there's also a ceiling function, which will round up. So if you did math.ceil, that will round up. And there's a bunch of functions under the math library. So the key with the math library is you import math, that brings in a library, and then you can say math dot and use different functions which are available to the math library. I think I give you a link here to the math library. If you click on that, it will open up and you can look up all the different functions that are in the math library. Square root is a function from the math library. So from math, so before we did import math, and then we had to put math dot to get to the function. If you don't want to have to type math dot everywhere, you can do it this way. So here we're going to import the square root function. And here we're saying from math, just import the square root function. So here we're not importing everything from math. And if we do that, then we don't have to put math dot. We can just put square root. And if you put square root of 9, it will give you the square root. Now, you don't have to do this one, but you can actually rename functions. You could say foo equals math dot square root, and then foo would become actually that function. So that's provided because sometimes you import things from libraries and you need to rename them so that you can deconflict functions in different libraries. Okay, now there's a section here that goes into complex math. CMath is a complex math library that can deal with imaginary numbers. I don't want to go through all that. I'm going to skip over this section. And I want to get to what we need for the next program, which is we need to know how to write a program. So a program is basically an algorithm. And what an algorithm is, so far what we've done with the interactive interpreters, we've just written one line of code and then it's immediately executed it. A program is actually a whole series of lines of code and they get executed one after the other. And so a computer program is like an algorithm. So to make a program, we could use Notepad or Notepad++, but IDLE gives us an editor. So we're going to make a little program right now. We're going to make an addition program. And to make a program, what you do is go to your shell and go to File and click on New File. So you're follow along. This will give you a start on the next program. And so here we have a new file, and what will happen is, and what I generally do is I will put my program and the interpreter on side by side. And the first thing we typically do is we create a comments. We use comments. And so the number sign in Python actually makes a comment. And what that tells the computer to do, or Python to do, is just ignore this. This is just a comment I'm using to comment my code. And so we're going to call this addition program. And it's going to programmer Rob Garner, R Garner 7 cnm.edu. I usually put the date, which is 3 September 2020. And then I usually put a purpose, add 2 numbers. And I'm going to save this. And I'm just going to put mine on my desktop. I'd recommend making a folder structure and saving them, by program. And always, when you save it, put the extension .py. Python will not automatically add that, and it helps opening the program and accessing the program if you put .py. So I want to add 2 numbers. And what I usually do is I will start off my program just by writing comments. So to add 2 numbers, I'm going to get 2 numbers from the user. Calculate the sum. And then display results. By the way, this is kind of the standard pseudocode that you would have in almost any program. And then maybe I'll even here print a welcome message. This is called pseudocode. And it really is helpful to break up your program and write it out like this before you start writing your program. Because now, rather than one big problem, I now have 4 smaller problems.
Real quick, how did you get the numbers on the left side of the screen?
Oh, that's an option. And you can configure idle. I'm going to, let me change this to 20 smaller. And let's see, where was that? It's one of these in here. Initial at startup, open window. Maybe it's not there.
Is that not necessary? We don't need to have the numbers?
You don't need it, but it makes it a lot easier when you're looking, because when you have errors, it will tell you which line number it is on, and that makes it a lot easier. You can also tell what line number you're on is down here on the right. Here it tells me I'm on line 8. But let me see, run.
If you go options and then show line number, like right under. Like it was in the drop down for me with options.
Oh, with options?
Yeah.
Okay.
In the settings under general, it also says
okay.
show
Mine's
line
hide.
numbers and new. Yeah.
Yeah, mine said hide. That's why
Got it. That works. Thank you.
Yeah, that's really helpful. Okay, so what do I do if I want to print a welcome message? What command, what statement would I write? And sometimes my questions aren't hard.
Print.
Yes, print. So, we put in welcome to Super additionator 3000. You know, we get the name from the marketing department, so they want that so people will buy it. Marketing doesn't care about grammar. Okay. And then what we want to do is we want to get two numbers. So what would I write to get a number from the user?
Input.
And so would I just do it like this, and then notice actually if you pause a little bit, it comes up with information. So input, please enter a number. So just like that. So let's give it a try. I'm going to run this. To run your program, you go to run. You'll notice there's a run function that says run module. There's shortcut keys here. So in this case, F5 is a shortcut key. What I recommend is, in order to memorize the shortcut keys, go up. Initially, you won't remember them. So just go to the menu and look there and look up the shortcut key. Then close it and then hit F5. And what will happen is after you do that a certain number of times, it'll actually run. So here we see, welcome to Super Additionator 3000. I put in a number. Where did that number go? It actually just disappeared. We need to do something here to keep that number. What do we need to do? We need a variable. So when you're doing inputs, remember you need a variable. Yes, and actually that's a better variable. So and now presumably second number. And what I recommend is every time you write a couple lines of code, hit F5 and run it, and just make sure that now you have some values. And the cool thing is here, after it stops, you can actually type in your variables and see what actually is coming out. So, okay, we got first number and second number. How would I add these together now? Someone made a good point. What are these, strings or numbers? Yeah, so if I could do this. Yeah, those are strings. Notice if I add 5 and 5, I get 55. So what do I need to do? I need to convert them to numbers.
I had a quick question. Anytime I run the module, it just says invalid syntax.
Okay, so does it give a line number?
No.
Oh, if it's invalid syntax, sometimes what it'll do is, does it kind of have like a red highlighted section that gives you like it's sitting next to something?
Yeah,
So-
I think like the T in Welcome to Super Editionator's highlighted for 2.
Yes, so it might have been something like this. Let's say if we forgot the quotes. And then if I run this, does it look like that?
Yes.
So what,
Oh.
so what happened was, is we need to have quotes around our text.
Oh, okay. Oh, okay, there it goes. Okay, thank you so much.
Yes, so someone identified that the problem is that these are text. So we get somewhere we have to convert these into numbers. Now you could do it here like this. And that would work. What I'm going to suggest, though, is that actually you do that right when you get input. And that's because throughout this, then you know that these are, you're calling these numbers. It makes sense to have them be numbers right from the get-go. So now we have this working. We have our inputs being converted to floats. The other thing I'm going to do is I'm going to actually store this. I'm going to make another variable, and I'm going to store this result in a variable, and then I'm going to do the print here.
Can I ask why you put the double end brackets at the very bottom of the first and second number? Do you know what I'm talking about?
The double and like the
Yeah, you added an additional bracket after. Okay, will that affect the code if you don't?
Yes, because we actually have two functions happening here. We have this input, which has an open and closing parentheses, and then float has its own opening and closing parentheses. So what's happening here is this is giving me back a string, and then I'm taking the string and passing it to the float function. And the float function is taking this string and turning it into a number before it gets assigned into this variable.
Okay, that makes sense. Thank you.
That's a very good question. And this is kind of because we're having multiple things happen. Sometimes that's confusing, but in programming, we often do that where we take the output of one thing and put it directly as the input of the next thing. Now with your print statement, if you want to display multiple things, you can put them in and separate them with a comma, and it'll automatically put a space between them. So if we do this like this, I can put 8 and 9. The sum is 17, and you notice it automatically added this space between these two. And you can put multiple things in here separated by comma, and it'll print them all out. Did that work for everybody? I'll wait till everyone gets that to function.
Yeah, it worked.
So I'm having a invalid error as well. Mine's showing line 10 and it's highlighting the F in red.
So if it's highlighting the F in red, let's see if it was this. So it's not that. It could be this. Is it like that, or is it?
Yep, it's just like that.
Okay, so most likely you're missing a closing parentheses on your print statement, or maybe a closing quote. It could be this as well. I'm guessing you're missing the closing parentheses on your print statement.
And I also had a question too, just because I'm getting a error syntax for, I believe it's 14, line 14, and it's highlighting the letter N in number for first.
So like here,
Yes.
now that could be maybe a space in there. So if you had it like that, for example, if I ran that, that might be it. Because your variables have to be one solid variable.
Oh,
So
okay.
So there's an underscore there.
Oh, okay. So it's an underscore. That's what that
Yes.
is.
Yes. Those are good because if people don't see those, that you will typically see them at some point in time. So this helps out. Let's see
Oh,
some
okay,
other.
perfect.
Yeah, and so common problems that happen are not closing things out, like missing. Like this is very easy to do. Is you close that parentheses, but you miss the closing one. Forgetting quotes is another one that's pretty common. Let's see, what other errors do I see a lot of? And then one that's going to affect you is you start writing your code and you forget to assign things into variables so that you can access them later. Notice the pattern it's here. We do something, we store it in a variable. We do something, we store it in a variable. Then we use those variables and we store it into another variable. And then we take that variable and we display the results. You're a lot of times storing intermediate results in variables. What kind of error are you getting, Derek?
I'm still getting the same error. It wasn't, it doesn't appear to be what you were thinking it was initially. It's still showing, my line of code looks, as far as I can tell, identical to yours. I can't see any difference between the two.
Which line is it again?
It's line 10 and it's the F in the letter first.
Letter first. So look up.
I'm sorry, in the word first.
So it's probably having to do something with that print statement above it. Often the error is going to be above the line of code. So it will be something. It'll be something above there that will drive the error. Yes. So what's happening here is we're doing a print statement, and this and so we can actually put comma, and we can put multiple things to print out separated by commas. So if I do that, you can see now I've got this dot here. Now, unfortunately, it does add a space, so that doesn't work great in this instance, but you can see I can put multiple things and separate them with a space.
I was getting an error on the idle, or not the idle. Yeah, the idle part of it. And because whenever I go to run the module, I enter it in, and then once I enter in a number, it says traceback most recent call, and it says line 11 in module, second number, float input. It says a name error, second number is not defined. So I just don't know what to do with that.
So it says second number is not defined on the input.
Yeah, it's a second number in the float input. Please enter another number with the double commas in line 11 is, I guess, not defined.
So that might be, let's see if I can recreate that.
And then also underneath calculate the sum, is that SUMMAAT_ION?
No, it's just summation.
Okay.
Let's try this. Can you share your screen?
Yeah. Do I just request control or what?
There's actually, let me pause on that and let me handle some of these in the office hour. I noticed we're getting close on time. I want to go over the assignment first, and then I will fix the code that's missing. So
okay.
Let's see. So if we go to the bottom of the module here, under is the program you'll be creating. So using basically the same what we just worked with, you're going to make a program to calculate the area and volume of a pyramid. And so just like we did with this program here, you're going to enter, instead of first number and second number, you're going to enter floating point numbers for the base and the height of a pyramid. And given the base and the height of a pyramid, A and H, we can actually figure out the volume and the surface area of the four sides of the pyramid. For the volume, it's a simple formula, A squared times H divided by 3. So you'll use the formula stuff that we looked at to calculate that. And then to figure out the, and so what I would recommend to do this program is first write the code to get a base and height from the user. Then once you have that, put in this formula, and just like we're doing with this program, just calculate the volume and display the volume, because that's going to be very similar to what we just did, except a slightly more complex formula than addition. So you use the things that we use today to do squared and division and multiplication. And then the next thing is to figure out the area of the four sides of the pyramid. Now to do that, you've got to figure out the area of one side, and to figure out the area of one side, you need the slant height. So the slant height is, for this pyramid, would be this segment that goes from the top of the pyramid down to midway between the base of the pyramid. And to figure that out, we actually give you a formula. So the slant height is the square root of H squared plus A divided by 2 squared. And we saw that we have to import math to get the square root function. And if you look at that code in the slides for how to get the square root function, you're going to pass into the square root function H squared plus A divided by 2 squared and store that as slant height. And once you have the slant height, the area of one of the sides of the pyramid is just the area of a triangle, which is 1/2 base time height, which would be S times A divided by 2. And then to get the total area of all the four, you just multiply that by 4 and then display that to the user. So what I would do is I would break this program up this way. First, get base and height from the user, calculate volume and display volume. Then I would calculate the slant height. And before I do anything else, I would just display the slant height and just make sure that that's working. Then I would go back in and figure out the error of one side, display that, make sure that that's working. And then I'd multiply that by 4 and display that and make sure that that's working. So rather than doing this all in one big jump, do each individual piece and do this as basically 3 or 4 small little projects and, within the same program, but just add a little bit of code and run it. Add a little bit of code and run it. Add a little bit of code and run it. Does that make sense?
Yes.
Yep. And that will be due a week from now. So the following Wednesday, that means you get the weekend. And then if you have any questions, you can ask next class period and we can clear those up. And then it'll be due. And then you have actually another class period, which will be the next Wednesday one. And then it's due usually, I make them due at midnight, so you have multiple opportunities to ask questions. If you have any questions, you can post them in Teams. Let's use Teams for questions that are, that everyone else might be interested in. If you can, don't post too much of your code. Otherwise, you're just doing it for everybody. But, ask. And then if you have things that you don't want to display in Teams, use email to ask me questions. So that's basically what I have for today. I'll stay online here for my office hour. And if you need help getting this to work, just let me know, and we can share your code. And you can share your screen, and I can help you debug what's going on. And to share your screen, basically, let me see if I can show this. Down here, there's this. Oops. This little symbol right here, this is sharing. It's to the right of the microphone. That's how you share. So if it's not visible, let me know. I may need to change change what you are to make that work. And yes, copy and paste my code. I can do that. Push that to. So that's all I have for today.